Humanity first broke into Jupiter's interior. Is the main point what it discovered? What is truly terrifying is how it actually died. After it went inside, in 1995, NASA executed an extremely crazy mission. They built Galileo, and then threw it directly into Jupiter. From the beginning, this was a one-way mission to death. 147 days before plunging into Jupiter's atmosphere, the Galileo orbiter and the probe officially separated. After several explosive nuts were detonated, the probe spun and flew out like a bullet from a barrel, charging toward the target 81 million kilometers away. This hit had to be absolutely perfect. If too steep, it would be burned through before it even had a chance to send data back. If the angle was too shallow, it wouldn't even enter Jupiter at all. From this moment on, there was no turning back for it. It could only fly toward that massive planet alone, to collect first-hand samples that humanity had never obtained before. 14 days after separation, the orbiter readjusted its direction, firing engines for orbit, and leaving the probe's doomed path. Because the one that actually rushed in was not the orbiter. The orbiter only stayed at a distance, to receive the data sent back by the probe, and then forwarding that data back to Earth. 9 days before entry, the orbiter opened its antenna. Because once the probe plunged into Jupiter's atmosphere, it would only have a few short minutes to lock onto the signal. Without a lock, all mission data would be lost. Would be lost inside Jupiter forever. 6 hours before entry, the probe officially started up. Instruments asleep for nearly 10 years were finally powered on again. And this also meant it had already crossed the true point of no return and entered Jupiter's inner magnetosphere. That was a completely unfamiliar region, packed with high-energy particles that almost no one had truly studied before. The environment was brutal. The first to wake up was the high-energy particle detection equipment. It began desperately recording the environment, capturing up to 3 million particles per second. And while it was busy feeling Jupiter, another set of equipment also began to work. Scientists always suspected there might be lightning here. This hypothesis had already shown signs of promise in 2 nighttime photos captured by Voyager 1's flyby. The problem is that lightning on Earth is usually related to the ground, but Jupiter has no solid ground. So, whether Jupiter's lightning actually exists, and how it is formed, no one knew for sure then. Therefore, a small window behind the heat shield at the rear of the probe began listening for radio signals from inside Jupiter. If there was lightning, it would leave an electromagnetic signature. But radio alone was not enough. Scientists also wanted to catch the light. So, the probe was also equipped with 2 highly sensitive photodetectors, each with a fisheye lens behind it, positioned 180 degrees apart to maximize the field of view. At 3 hours and 4 minutes before entry, the probe was only 360,000 kilometers away from Jupiter, and the measurements of Jupiter's inner radiation belt began. Over the next 3 hours, they observed once every hour, until they approached the edge of Jupiter's atmosphere. At 60 minutes and 38 seconds before entry, Jupiter kept expanding in the field of view, until it filled the entire sky. The probe began to continuously record everything around it. 3 minutes prior, the orbiter, flying at an altitude of 214,000 kilometers, began executing a new set of commands. And the onboard tape recorder also started up. Beneath it, the probe had already begun its descent. Like a dart thrown toward a massive bullseye, flying 800 million kilometers, it was about to plunge into its target. At this moment, its speed was as high as 47.4 kilometers per second. The entire probe was about 1.24 meters at its widest, and about 86 centimeters high, yet its weight was almost comparable to a vending machine. It had 2 parts: the outer shell responsible for deceleration and ablation resistance, and the actual descent module inside. The outer shell had to take the brutal atmosphere first, to bring the speed down, before the probe could deploy its chute and continue down. And the most terrifying thing about Jupiter is that it has no familiar surface. There is no solid ground for you to step on there. There are only endless gases, storms, and ever-increasing pressure. So on Jupiter, altitude is not measured from the ground, but rather by atmospheric pressure. Scientists stake the location where the pressure equals 1 atmosphere at Earth's sea level, and define it as Jupiter's 1 bar level. When Galileo descended to 450 kilometers above this 1 bar level, it officially entered Jupiter. Atmospheric entry was incredibly perilous. Its entry speed was just 4 kilometers per second slower than its limit. Any faster, the entire probe would have burned up instantly. When it broke through, it meant truly piercing Jupiter's outer atmosphere for the first time. As soon as the probe entered, the atmospheric structure instrument immediately began to work. What it needed to record were the changes in temperature, pressure, and descent speed. Because from now on, what Galileo faced was no longer space, but layers of increasingly frantic Jovian atmosphere. Right after entry, external temperatures hit 352 degrees Celsius. This temperature was enough to easily destroy those precision instruments inside. So the only thing it could count on was that the outer deceleration shell had to hold up. This shell system was divided into front and rear parts. The front was a heavy forward heat shield, and the rear was a relatively thin aft heat shield. The forward heat shield accounted for almost half of the entire probe's mass, and its tip used a carbon phenolic material. This material would carry away heat by constantly ablating. To put it plainly, its way of working was burn itself first to let the inside survive. 35 seconds after entering Jupiter, the true violence began. Over the next 15 seconds, the probe endured a terrifying deceleration of 228 gs. In just a brief moment, it plummeted 230 kilometers. That was supposed to be the upper atmosphere, a place that should be very cold. But the heat surrounding the probe was fiercely absurd. Front temperatures doubled that of the sun's surface. At this moment, it did not look like a probe at all. It looked more like an artificial meteor. The heat shield began to crack and peel off, trailing a wake of vaporized metal behind it. 80 seconds after entry, the most brutal deceleration phase was finally over. But a price had to be paid. Over half the front shield was gone. In less than 2 minutes, 90 kilograms of mass was simply gone. Next, it was time for the parachute to make its entrance. The probe had slowed down to a speed where opening the chute was theoretically possible. Yet at 0.1 bar when the chute should have opened, it did not. Crossed switch wires messed up the timing. This meant that the extreme heat, braking, was nearly for nothing. The probe plunged downward as pressure kept rising. 0.1 bar, 0.2 bar, 0.3 bar, it just kept falling straight down. Until 0.41 bar, when it suddenly came back to life. The retaining cables were cut and the cover panel popped open. The pilot chute was pulled into the wake. And then, the main parachute pack was also yanked out. Nearly 3 minutes after entry, the rear shield detached, falling into the rapidly cooling wake behind the probe. At this moment, the ambient temperature had already dropped to minus 145 degrees Celsius. Now, it was only 23 kilometers away from Jupiter's 1 bar level. The pilot chute violently yanked the main parachute out. The main chute deployed and rotated, separating descent and braking modules. The entire sequence was completed within 1.2 seconds. Mind you, this was deployed at a speed close to Mach 0.9. So this parachute had to be strong enough. It was made of Dacron and Kevlar materials. 9 seconds later, the front shell was blown away. From this very moment, Galileo had truly floated into the skies of Jupiter. Not landing, as there is no ground here. It was simply in an unfamiliar alien world, falling deeper and deeper. Then, new instruments began to work. A metal arm extended out to analyze Jupiter's cloud layers. It would probe kilometer by kilometer, trying to figure out what these clouds are actually made of, and their status. As the outer shell was discarded, the inner descent module itself was finally completely exposed to the Jovian atmosphere. 3 minutes after entering Jupiter, as the outer shell fell 30 meters away, the science gear woke up sequentially. The descent module carried 7 main instruments. They were the true purpose of this suicidal journey. The probe had to send the collected data to the orbiter high above first. which would then relay it to Earth, 778 million kilometers away. Yet, these critical science instruments weighed only 28 kilograms in total. At this moment, the probe was 21 kilometers above the 1 bar level, descending at a speed of about 650 kilometers per hour. As the main parachute began to truly catch the Jovian atmosphere, its speed was further reduced to 430 kilometers per hour. At 3 minutes and 2 seconds into entry, the first direct sampling of Jupiter's atmosphere began. The pressure at this time was 0.42 bar. Due to the parachute delay, this step was later than planned. While the probe was sampling, it hunted for the orbiter's signal. For without it, everything it was collecting right now, it's lost. Another minute passed, and it finally locked onto the orbiter. By this time, it had dropped another 4 kilometers, and the pressure jumped from 0.42 bar to 0.56 bar in less than 30 seconds. At 4 minutes and 8 seconds into entry, the orbiter finally received the data transmitted from it. Within a few seconds, the backup data saved so far, together with the real-time sampling data, was sent out. Galileo had already penetrated a 450-kilometer thick layer of clouds and gas. When it crossed the 1 bar level, in a sense, it reached the surface of Jupiter's atmosphere. And from here on, the extreme cold of the outer layers began to gradually give way to the heat deeper inside Jupiter. The temperature climbed all the way from minus 135 degrees Celsius back to minus 107 degrees Celsius. It still sounds cold, but it will only get hotter and hotter. At 9.5 minutes in, temperatures kept rising, reaching minus 80 degrees Celsius at 1.6 bar. And this was just the beginning. Next, a very critical measurement commenced. Because the probe was not just here to study Jupiter, it could also help humanity find clues to the much earlier universe. When the external pressure reached 2.5 bar, the thin metal membrane inside the helium abundance detector ruptured. The reference gas and the Jovian atmosphere began to mix, and tracking began. The reason is simple. Hydrogen and helium dominate the universe. Yet their cosmic post-Big Bang ratio has always been a very critical question in cosmology. And gas giants like Jupiter may act like a giant time capsule, preserving the very ancient element ratios. If measured, we will not just know Jupiter better, but might see the universe at its birth. 22 minutes in, first direct chemical sampling done. By then, pressure hit 3.8 bars. As the probe entered the predicted water cloud layer, temperatures hit 0 degrees and 5 bars. At this moment, it had already fallen 56 kilometers below the 1 bar reference level. As it continued to sink, temperature variations began to create more complex heating and cooling zones. This variance drove fierce atmospheric currents, dominating Jupiter's circulation. Therefore, other gear trapped heat flux and radiation. Trying to figure out exactly how these violent air currents inside Jupiter operate, a small optical probe extended out from the spacecraft, looking out at the external radiation environment through a hard diamond window. To prevent water vapor condensation, it was even equipped with a heating device. Since the atmospheric composition changes with altitude, round 2 began at 8.6 bars. By design, Galileo only needed to hold out until about 10 bars to be deemed a success. In other words, at around 35 minutes, it could have already died a worthy death. But it did not die right away. 41 minutes in, it was still there. This was like a machine that had been sentenced to death, stubbornly holding out for an extra period of time. With this bonus lifespan, second mass spectrometry round ended at 12.1 bars. 49 minutes in, it continued to dive into deeper, hotter regions. By the time it reached 15.8 bars, scientists even started a third round of sampling. Since it was not dead yet, they might as well keep gathering data. But Jupiter would not show mercy forever. 51 minutes in, one transmitter died first. To prevent a single point of failure, Galileo was originally designed with 2 parallel data transmission paths. Now, one of the paths was gone. Over the next 12 minutes, the signal from the remaining transmitter also began to waver. It flickered on and off, fading in and out. This indicated that the sealed equipment box housing the transmitter warped under extreme heat and pressure. Then, after a full hour, dead silence. The mission ended in silence. The internal temperature of the probe had risen to 153 degrees Celsius, and it had already traveled 146 kilometers below Jupiter's surface, far exceeding its originally expected destination. 20 minutes later, the orbiter turned off its receiver, stowed its antenna in Jupiter's orbit, to begin its own subsequent dangerous journey. But for the probe below, the real end had not yet arrived. Deeper down, an environment capable of vaporizing metal awaited it. As it continued to fall into lower regions, Jupiter began to truly tear it apart. The first to melt was the parachute. Then, the descent module, losing its deceleration drag, began to free fall. The aluminum parts melted first. Within a few hours, the aluminum body also completely vaporized. 4 hours on, even the titanium outer shell and the instruments inside melted together. Another 2 hours after that, at pressures 5,000 times Earth's surface, and a high temperature of 1,700 degrees Celsius, even the titanium evaporated. Finally, Galileo completely disappeared. There was no wreckage, and no crash site. It was completely atomized, becoming a minuscule part of Jupiter. Humanity's first probe to venture into Jupiter's interior was brief, yet magnificent enough. It left the answers with Earth at the very last moment, while becoming a part of Jupiter forever. I am Lauma, see you in the next universe.